lesson, we're going to go ahead and take a look at the distance formula, and we're going to see how it's related to one of the famous theorems we know called the Pythagorean theorem. So, distance. Well, first of all, what the distance formula tells me is if I have 2 points, so let's say that this point right here is x comma y, and we'll say x1 and y1, just like we do for midpoint. And this point over here is x2 and y2. Well, in order for me to find the distance, we have this formula which says take the big square root of x2 minus x1, square it, and then add y2 minus y1 and square that. So that's how we can find the distance. Well, let's use the problem here, and let's find the distance between those 2 points. So my first value is at 1, 5. And the value over here on my left is -2, 1. So I'm going to go ahead and plug those in to the distance formula. Here's x1, here's y1, here's x2, here's y2. So it's going to be the square root of -2 minus 1 squared plus, well, y2 is 1, subtract 5 and square it. So I end up with the square root, well, -2 minus 1 is -3 squared plus 1 minus 5 is -4 squared. Well, -3 squared is a +9 plus a -4 squared is 16. So I have the square root of 25, which is a perfect square, which means that distance is 5. So the distance between these 2 points is 5. Well, there's another way that we can go ahead and find that. If I were to draw the distance between those 2 points, that would be that diagonal line. Well, I can also draw a triangle and show a triangular relationship between those points. And the triangle I drew was actually a right triangle. So since I have a right triangle, I can go ahead and apply the Pythagorean theorem. And what the Pythagorean theorem says is if you take one of the sides, and we'll call it A, and you square it, and you add B squared, so another side squared, that's going to equal C squared, which is what we're trying to find, the hypotenuse, which is the distance between those 2 points. So let's go ahead and do that. If I needed to find A, well, A is the length, and the length here is 1, 2, 3. So this would be 3 squared. Plus, my B value, well, it's 1, 2, 3, 4. So 4 squared, and we're trying to find C squared. Well, I know 3 squared is 9, and I know 4 squared is 16, and that equals C squared. Using the distance formula, I saw those numbers, 9 and 16, right here. But I ended up taking the square root of 9 plus 16. And the reason why we did that was so we can find the distance. Well, look down here with the Pythagorean theorem. If I wanted to get C by itself, I would just take the square root of both sides. So the square root of 9 plus 16, which is 25, is C, and 5 is my hypotenuse, which is the distance between the 2 given points. So really, the distance formula is just the Pythagorean theorem. Hopefully you can see how those 2 things are related. So what I would like you to do is I would like you to find the length of the hypotenuse of the triangle. I want you to use the distance formula, and then I want you to use the Pythagorean theorem. So go ahead and try this on your own, and when you're done, come back and we'll see how you did. So the hypotenuse, the endpoints are here and here. So one of them is 3, 2. And the other one is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So if I want to use the distance formula, I'm going to take the square root, and I'm going to take 3 minus 7 squared plus 2 minus 8 squared. Well, 3 minus 7 is negative 4 squared. 2 minus 8 is negative 6, and I'm going to square that. Negative 4 squared is 16, plus negative 6 squared is 36, which equals, well, 16 plus 36. So if I add 36 here, 6 plus 6 is 2, carry my 1, 52. So I get the square root of 52 as that distance. Now I don't want it as a decimal, but I could go ahead and try to break down the square root of 52. Right? If I took 52 and I tried to break it down, I could go 2 and 26, 2 and 13. Well, they're all prime numbers now, so I circle my pairs. 2 times 2 is the square root of 4. Square root of 13 stays in a radical. Square root of 4 is 2. 13 is going to stay inside the square root, so it's actually 2 square roots of 13. Well, now if I want to find the length of the hypotenuse using the Pythagorean theorem, I'm going to find the length of this side of the triangle, which is 1, 2, 3, 4. The length or the height of the triangle is 1, 2, 3, 4, 5, 6. So using a squared plus b squared equals c squared, I'm going to say 4 squared plus 6 squared equals c squared. So 16 plus 36 is equal to c squared. Those are those numbers again, the 16 and the 36. 16 plus 36 is 52, which equals c squared. Take the square root of both sides so I can get c. Well, we already know how to break down 52. We get 2 square roots of 13 as my c value. So distance formula, Pythagorean theorem, they give us the same answer. So here's what I'd like you to try now. I want you to find the distance between the midpoint of C and D. So try this. Pause the video and come back when you're ready. So you're finding the midpoint between C, or the distance between C and D to start with. So to do the distance, I'm going to take 3 minus a negative 1 squared plus negative 2 minus a negative 7 squared. A negative and a negative would be a plus. So it's going to be the square root. Well, 3 plus 1 is 4 squared plus negative 2 plus 7 is 5 squared. Well, this is going to be the square root of 16 plus 25. And 16 plus 25, so let's add 25 to that, is going to be the square root of 41. I can't break down 41 because it's a prime number. So there is my distance. Let's go ahead and now find the midpoint. So if I'm going to find the midpoint, I'm going to take my x's, which are 3 plus a negative 1, divide by 2. And then I'm going to take negative 2 plus a negative 7 and divide by 2. Well, 3 plus negative 1 is 2 over 2. And negative 2 plus negative 7 is negative 9 over 2. And that simplifies to 1 and negative 9 halves. So there's my distance, and there's the midpoint.